So we are continuing with lecture 1 of AI. So, what are the different types of tasks? We were talking about tasks in the last video, that AI has to, or the intelligent, in the definition of intelligence we were saying that it's the computational ability to achieve goals, means to do some tasks. So what are the tasks? So broadly, for our study, we have divided tasks into two parts. One is common tasks. What do you mean by common tasks? The tasks that we do on a regular basis, like recognizing people. We do this any time of the day, any time, in different illumination, different faces we remember and we recognize. We do natural language communication in different languages, like I am doing with you right now. We do navigation on streets. And while doing that, we do obstacle avoidance also. We do not hit a car, we do not bump into people. All these things, and there are many more, are common tasks. The other type of tasks that we talk about are called the expert tasks. And what are the examples of expert tasks? Examples of expert tasks are, for example, when you get ill, you go to an expert. He is a doctor. So, medical diagnosis is an expert task. Solving difficult maths for engineering and technology and science problems. Mathematicians do that, and researchers do that. So math solving, expert task. Not everyone is a very good chess player. Chess playing, expert task. Designing bridges, designing houses, engineering design. Expert task. So all these things are expert tasks. So till now, if we look at the history of AI development, we will see that AI systems that have been developed till now are more able, are better at targeting these expert tasks rather than common tasks. Expert tasks, there are systems that I will give you some examples readily. For example, I will tell you. In 1959, the algebra solver was developed. was developed in 1959. The geometry engine was also developed during this period. There was a program called the Dendral. It was developed in 1967. It did perform spectrography analysis for chemistry. In 1969, in 1969, a system called Mycene was developed for medical diagnosis assistance. In 1997, Deep Blue, a program which beat Garry Kasparov in chess, this was developed. So I have given you some examples, some very prominent examples of AI programs that have been developed over the years, and they are mainly successful at expert task, and again expert task. But there are very few programs, even till now, that have foolproof success at common tasks. There are very few programs like that till now. And I can assume that you within your own mind have a fair bit of explanation for this. And what is that? Because I can tell you a rule how to solve a particular algebraic equation. I can tell you a rule or a methodology in which usually spectrographs are analyzed, or to some extent there is a defined pathway or objective pathway in which a doctor goes for a medical diagnosis. There are some particular defined discrete moves in chess, but then you have to search through moves which are better at that present time, but the moves are defined, that this is the rule, you cannot do this, you can do that. The rules are defined. On the other hand, in the contrary, in common tasks, you come to common tasks. If I ask you that you recognize your friend, you say yes. If I ask you how, you won't be able to explain. You won't be able to say how you did that, how you recognized, how did you understand what he is able to say. Natural language communication. What is the greatest problem of natural language communication? The biggest problem is ambiguity. We humans use the same words for different meaning in different expressions. We use different figures of speech like sarcasm. What is sarcasm? I say something, in words I say something, but I mean something else. For example, when you make a stupid statement, your teacher or your parent may comment, "Ooh, such a smart guy." The sentence is "such a smart guy," but the meaning is you are not smart. You are not smart at all. So the literal meaning of the sentence and the intended meaning of the sentence are different. This is ambiguity. And this is the main problem which computers cannot understand. But we human beings can. Navigation on streets. We do that so... I will tell you, start from Manushakti Nagar and go to Chembur. You will do that without hitting any person on street. And you will plan your way. You will either plan to take an auto. If the auto is not available, you will take a train from Mankhurd. So on the fly you will change your plans. You will know what is the best option available to you. Is it raining? Will it affect your travel? So all those things you can do so spontaneously. In commonplace tasks, the rules of the game are very fuzzy, and hence, yet till now, commonplace tasks are not very well done by AI, although some AI components, as you may have heard, like neural networks, deep neural networks, are at present targeting those tasks to a fair amount of accuracy, but not what we expect it to be. Not, again I will tell you, not like humans. Maybe in the last video only I said that not all human-like behavior is intelligent behavior, but at least for superseding humans, before superseding humans, we should at least reach the level of humans. Almost no algorithm has reached the level of humans in these commonplace tasks. So, till now, expert tasks are the area in which we are more successful at. So while we study AI, or while anybody studies AI as a subject, since slowly we are going into the subject matter, what are the areas that we are going to attack? That we have to attack for doing real world problems. We have to do problem solving. Different types of problems can be there, we will see. We have to do reasoning. Reasoning is a thing which we do continuously within our head. We get some information from the real world, and then we use our reasoning abilities, our logical abilities, to infer some new information and use it for our own good, to our advantage. So reasoning. We plan before doing a task. We do planning. Even if you want to go for a trip, you plan your trip. Whenever you want to go out for doing your household chores or buying your month's things, so you plan what are the list of things that you need to buy. So each and every stage of your life, be at the broader scale, be at the smaller scale, we are always planning. And I should not say last, but one of the pillars of intelligent behavior is learning. As and how we do tasks through these things, we will get more and more experience about the real world, and we can digest those experience into more of our capabilities through this process of learning. By learning, we take experience from the real world, and we reduce our errors which we were doing. We are not perfect on day one. We do some task on day one, we do some errors. We learn from our mistakes. We do some mistakes. These learning things gives us the ability to learn from our mistakes that what we should do or what actions we should not do to avoid those mistakes. On day 2, our actions are a bit more improved. On day 3, a bit more. So this learning process gives us the ability to refine ourselves in doing the real world tasks, and hence learning is one of the biggest pillars of intelligence. And as you know, these days machine learning, deep learning, artificial neural networks, all of them are trying to achieve intelligence through trying to perform intelligent tasks by learning from what? Experience. What is experience? From data, from old data. From machine learning is about learning from old data to perform the same work in a better way in the future. So learning is one of the biggest pillars of artificial intelligence activities. So there are two main approaches to AI. What are the two main approaches? One is called the strong AI. What is strong AI? Strong AI is really sci-fi thing. Strong AI is, it has got self-awareness, or I should say a very philosophical term, consciousness. It's more philosophical. So some people argue that what we humans are we liver, heart, kidney, some muscles, some flesh tissues, some hormones, some blood, some lymph? That is it? Is it a brain? That's it. Some neurons? That's it. Some people say no, there's more to it. There's something called consciousness, but nobody knows how to define it. So from a philosophical point of view, strong AI is about consciousness or self-awareness. We are not going into that. We will go what is called weak AI, the more practical thing. It is some AI in the form of a softwares or electromechanical objects with software like robots and all, that can reason and solve problems for doing some task to help human beings, I should say. If I bring an analogy to Industrial Revolution, so here we are also aiming to help human beings. So much of the weak AI is achieved through the present so-called, whatever you see around, smart systems, smartphone, to some extent face recognition softwares which are used in the access control in banks, in cooperative housing societies, all those things. In smart systems, as in air conditioners, smart air conditioners, if the sensor senses excess amount of humidity, automatically it tries to dry up the air. You don't have to manually operate that, it automatically senses and takes a decision on its own. So this is about weak AI. It's trying to reason and help and solve some problems and do some manipulations on the environment within a very limited scale. The universal AI which can do everything. Now the weak AI is very task specific. That is why I said the software that is working within the smart air conditioner will not be working within the robot. The software that is working within your fuzzy logic based washing machine, which senses the load and takes in the proper amount of water and decides the amount of washing time required, will not be is not the software required, or is not the sufficient software for your smart solar power system. So each weak AI system or each weak AI software are very task specific or application specific. So these are the main two approaches of AI. So many applications of AI we are seeing these days, like you can see these days, like Siri, Alexa, then